Hi guys, I'm Prof. Mish, and today we're going to talk about Bezout's lemma. What is Bezout's lemma? Okay, so Bezout's lemma states that if A is relatively prime to B, then AX plus BY equals 1 will always have a solution. So up there, we have a problem. 164x plus 37y equals 1, and we're going to find integers that satisfy that. Okay, our first step is to see if the two numbers on the left hand side are relatively prime. And yeah, they are relatively prime because 37 does not go into 164. Or the other way around. I might have said that incorrectly. But anyways, so yeah, our second step will be to figure out the larger number of those two, which is obviously 164. And you're going to write that larger number in terms of the other number, which will just be 4 times 37 plus 16. So now what we do is that we take this number, or the larger number of these three, which will just be 37, and write it in terms of the remainder, which will just be 2 times 16 plus 5. We repeat our step to get 16 equals 3 times 5 plus 1. When you want to stop when you have a remainder of 1. Okay, our next step is basically just rewriting these three for the remainders. So, for example, the first one would just be 16 equals to 164 minus 4 times 37, and 5 equals to 37 minus 2 times 16. 1 equals to 16 minus 3 times 5. Yeah. One important step when you're figuring out solutions to these types of questions is that you do not want to simplify any of your equations, because that will just ruin the point. Alright, so now we see a 16 right there, and we see a 16 there. So now we just substitute the 16 over this expression for 16 over there. And we'll just get 5 equals to 37 minus 2 times 164 minus 4 times 37. Simplify this to get 5 equals 37 minus 2 times 164 plus 8 times 37. We have 1 times 37 plus 8 times 37. We add them, we get 9 times 37. 9 times 37 minus 2 times 16. So let's erase this one up there and put this expression on that side. Okay. So now we move on to the next one. We have 1 equals 16 minus 3 times 5. We have an expression for 16 and an expression for 5. Yeah, so let's substitute that in. You get 1 equals to 164 minus 4 times 37. So this is the expression for 16. And for 5, you just have negative 3 times 9 times 37 minus 2 times 164. You expand it to get 164 minus 4 times 37 minus 27 times 37 plus 6 times 164. We have 1 times 164, 6 times 164. Add them, 7 times 164. You have negative 4 times 37, negative 27 times 37. Add them, negative 31 times 37. Oops. Alright. 164. 164. 37. 37. We just found our answer. You have x times 164, which is just 7 times 164, plus 37 times y, negative 31 times 37, equals to 1, equals to 1. So the integers that satisfy this 7 comma negative 31. So, okay, so now let's talk about modular inverses. What is a modular inverse? So if you have an equation, a congruency, ax, where a is a positive number, and you want to figure out what x is congruent to 1 mod b, where b is also a positive number, you can use the Bezout lemma. A congruency has an inverse if and only if a and b are relatively prime. So a has to be relatively prime to b. And we see, obviously we just see a similarity with Bezout lemma and modular inverses. A has to be relatively prime to b. We can rewrite this equation, or this congruency, in terms of algebra. What this is basically saying is that when ax is divided by b, it gives a remainder of 1. So when we rewrite this in algebra, we have b times some integer y plus 1 will equal to ax. Right. So let's isolate the 1. You have ax minus by equals to 1. Well, this looks oddly similar to ax plus by is equal to 1, except there's a negative sign. What we can do is we can just ignore the negative sign. We can just put a positive sign in the end, and all we have to do is remember to multiply the y value that we get in the end by negative 1 to get our actual solutions for the congruency. So just make a note somewhere if you're taking the test about this. Right. Now, yeah. So let's look at an example. Let's just look at the example that we did in the previous one. We had 164x plus 37y is equal to 1. So we can just write this as 164x is congruent to 1 mod 37. I know that what we can do is that we can just simplify this into 16x. It's congruent to 1 mod 37, but just for the sake of this video, I'm just going to keep it like this. So let's write in terms of algebra. 164x is equal to 37y plus 1. 164x minus 37y equals 1. Now we just follow. Now, as I said before, you can just make this into a plus sign. All you have to do is remember to multiply the y with a negative 1. So yeah, we solve this like we did before, and we get x equals to 7 comma negative 30 x comma y. X comma y equals to 7 comma negative 31, but since we want to multiply it by negative 1 in the end, we'll have this as a positive number. So when 164 is multiplied by 37, and when 164 is multiplied by 7, and then it is divided by 37, we'll have a remainder of 1. So that's it for today, guys. I showed you what Bezout lemma is and how to find solutions to questions such as ax plus by equals 1 using some arithmetic. And then I also showed you using that to find modular inverses. So yeah, that's it for today, guys. Leave a like, subscribe, and I'll see you next time when I will probably make a video about Fermat's little theorem. Bye. See you then.